This is R.D. Sharma solution, class 12, chapter 5, Algebra of Matrices. MCQ, we are taking multiple choice questions. Now this A is 1A01, then A raise n. So what we will do, you will see a pattern here. That is, when we multiply A with A square, I'll just find A square and you'll know the pattern. So let us do this A into A properly first. So this is 1 into A. You just assume that this is 1 into A. And we multiply it with 1A01. So A with A multiplication is going on. A square we are trying to find out. 1 into 1 plus A into 0, leave it. 1 into A into 1 is A. 0 into 1 is 0 and 1 into 0 is 0. 0 into A is 0 and 1 into 1 is 1. So what do you get? See, this is 1, 2A, twice of A. So initially I told you that this is 1A, now it is 2A. So if you do A3, this will come as 3A. You do 4A, it will come 4A. So this pattern is when you take A raise n, because as I said, A3, 3A, A4, 4A. This means, so whenever you do A raise n, it will be 1 and A01. This is your answer A. Now A is this and B is this. A into B is I3. I is the identity matrix. Then X plus Y equals. So we just have to multiply it. And when you see, one of the term will be X plus Y. Okay. So we'll properly multiply it. And then we will equate it to the identity matrix. A is this 1, 2x 0, 1, 0, 0, 0, 1. This is our first matrix. The next one will be 1 minus 2y 0, 1, 0 and 0, 0, 1. Now let us multiply. 1 into 1 is 1. 2 into 0 is 0. Leave it. X into 0 is 0. So 1 into minus 2 is minus 2. Minus 1 into minus 2 into 1 is 2 and x into 0 is 0. So minus 2 plus 2. 1 into y is y. 2 into 0 is 0 and x into 1 is x. Now the lower part, if you see, they are exactly like the identity matrix. Okay. So you will get exactly similar value, that is 0, 1, 0. I am not doing it. I hope you will be able to do 0, 1, 0. The lower part will be like the identity matrix. And this is equal to the I3. That is 1, 0, 0, 0, 1, 0 and 0, 0, 1. Right? Okay. So what do you get? If you see y plus x is equal to 0 in this case. Y plus x is equal to 0. So the question is asking about y plus x only. That is x plus y equals 0. So this is equal to 0. Okay. I hope you will be able to do this. A and B is this. A plus B whole square is A squared plus B squared. Then value of A and B are. So let us do step 1. That is, let us see what we get from A plus B whole square. So in this A plus B whole square, we will do this opening proper, A into B and A into B. Please remember, A plus B whole square cannot be written as A square plus B square plus 2AB. It cannot. It has to be written with A plus B into A plus B. So this is the proper multiplication we have to do. So what do you get? A plus B into A plus B. A into A is A dot A square. A into B, then B into A, then B into B, that is B square. And this is equal to what? A square plus B square. This is equal to A square plus B square. But what I am suggesting here is A square, B square gets cancelled. So AB plus BA is equal to 0. So AB is equal to minus B. AB is equal to minus B. So we will multiply A and B This A is A, this is B. And then we will multiply B and A. We will equate but with a negative sign. So let us multiply. 1 into A is A. 1 into minus 1 into B is minus B. Then 1 into 1, 1. Negative 1, negative is positive. So you get 2. So 2 into A then. And minus 1 into B minus B. So 2 into 1 and minus plus. So you get 3. This is the left hand side. Right hand side. Right hand side will be what? We'll do the negative later. First let us multiply. A1, A2, A plus 2. Then A into minus 1, that is minus A. And minus 1 into 1 is minus 1. So here B into 1 is B, minus 1 into 2 is minus 2. Then we have B into minus 1 is minus B, and minus is plus. So you have, so B into minus 1 is minus B, and minus is plus 1. Okay, negative is outside, so you just have to multiply negative 1 inside. So minus A plus 2 it will be, this will be A plus 1. This will be 2 minus B, and you can write this as B minus 1. It is not 1 minus B, it is B minus 1. I'll just change it. So A minus B, 2 minus A, 2, 3. Now let us equate. What is the equation? A plus 1 is equal to 2, and this is B minus 1 is equal to 3. This is 1 minus B, but it won't come. So this is going to be, let me write it as B minus 1. So B minus 1 is equal to 3. From here it comes A equals 1 and B equals 3 plus 1, that is going to be 4. So A is 1 and B is 4. Right? A1, B4, that is, this is the answer. B is the answer. Now A is given like this. A square equals I. Then you have to have this expression. This is alpha, beta, gamma minus alpha, and we are multiplying it again with alpha, beta, gamma and minus alpha. We'll equate with the identity. So there will be just multiplication, just equate, and that will be your expression. So alpha square, then plus gamma beta. It is not alpha, it is gamma beta. I'll just change it. Then alpha beta and minus alpha beta. So now here we have alpha gamma alpha or alpha gamma minus gamma alpha. Then we have beta gamma minus, actually it will be not minus, it will be plus alpha square. So this gets cancelled. Alpha square plus beta gamma, and this is 0, this is 0, and this is beta alpha, and as I said, minus will become plus, and we need to add it. It will be b alpha plus alpha square equals the identity matrix, that is going to be 1 0 0 1. Okay, now let us equate it. See, alpha square plus beta gamma is equal to 1. You can take 1 on this side, and from second also you get alpha square plus beta gamma is equal to 1. In both the cases you get this, not beta alpha, beta gamma it is. Alpha and gamma are mixing actually. So this is, but we need 1 as plus. If you see in the question, in the options being given, 1 is plus. So we have to multiply either both sides with 1, or you can take everything on the right hand side. That is going to become 1 minus alpha square minus beta gamma. Right? So we can rewrite this with negative multiplication or taking it on the right hand side as 1 minus alpha square minus beta gamma, because 1 is plus as I just said. So the answer is C here, because it will be 1 minus alpha square minus beta gamma. So this is C. C is the answer. Now we have Sij is a scalar matrix such that Sii is k, and A is a square matrix of the same order, then As into Sa equals what? See, scalar matrix is nothing but the identity matrix multiplied by a scalar value, right? So I'll tell you a trick here. In all these kind of question, if I take this as, because 2 by 2 matrix for example, so because Sii is k, so that I and j are equal, so this is k in the diagonal. If I take k common from here, what do you get? 1 0 0 1. Okay, now it is saying that A is a square matrix of the same order, then A into S and S into A equals what? So I'll just take any matrix, and if I multiply any matrix with an identity matrix, A into identity will always be A matrix. So identity matrix into A will also be the A. Okay, so identity matrix into A is going to be A, and K is outside. So whatever you do, it will be K into A. This is the logic. If A is a square matrix such that A square equals capital A, then I plus A whole cube minus 7A is equal to. So we are going to use this A square equal A in the expression, and I plus A whole cube minus 7A. First we will try to find out I plus A whole cube. That is, we are not going to apply A plus B whole cube formula. That is not valid for matrix. So we'll first multiply A with A, that is this I plus A with I plus A. So I into I is I square, that is I only. Then I into A, then A into I, then A square. So what do you see here? A into I is A only. Anything multiplied by any matrix multiplied by identity matrix will be the same matrix. So what do you get? This is A, this is A, this is I plus A, 2A it is. Now A square is already given in the question as A. Since it is already given in the question A square equals A, we have to multiply this whole again by I plus A. I am again saying I plus A whole cube we are not going to do. That is not possible here. It may come same, it may not, but we have to follow the proper procedure. So in place of A square, we will be putting A. What are we going to put? A. So this is I plus 3A. We have to multiply it with I plus A. Okay. Now let us do step by step. I into I is I squared. I already told you it is I. Then I into A. Then we have 3 into A into I. Then we have 3A into A. 3A square. So I square was I. I into A will always be A. This is A. This A into I will be A. And A square is A. This is A. So it will be 3A. I plus A plus 3A plus A with a 3. So 3A is 6A, A is 7. So this is I plus 7A. So I plus A whole cube was or has come as I plus 7A. Now you have a negative 7A. So just subtract 7A from here. It is going to be I. I is the answer. C is the answer. If a matrix A is both symmetric and skew symmetric, then see, we have already seen this can only be a zero matrix. I'll tell you how. Symmetric and A transpose equals A, that is symmetric matrix. A transpose equals negative A, that is going to be a skew symmetric. Right? In the transpose, Aij will change to Aji. That is the row and column we are exchanging. So Aij, when we are taking if we are saying that it is symmetric, then Aij has to be equal to Aj. This has come from the first relation, that is symmetric. Now when we take the skew symmetric, because it is being said A is skew symmetric also, Aij will be equal to minus Aj. Row and column will change. So now take this on the left hand side, Aij equals plus Aji is equal to 0. But from symmetric, Aij, you can replace it by Aj. So you can replace this Aj by Aij. So Aij plus Aij is equal to 0. That is twice of Aij equals 0. We have utilized it here, okay? So 2Aij equals 0, Aij is equal to 0, Aij equals 0 means all the values are 0, because Aij is nothing but it corresponds to all the value inside the matrix, and it is coming to be 0, right? Just put all as 0. This is a 0 matrix. Answer is A. This is a 0 matrix. The matrix this is what? So we'll just take the transpose. Let us take the transpose. So this is the row. I'm making it as column 0, 5, minus 7. This is a row. We're making it as column minus 5, 0, 11. 7, 11, 0. That is 7 minus 11, 0. Okay. Now I'm taking negative outside. 0, 5, negative 7. Negative 5, 0, plus 11. 7, negative 11, 0. What is this? This is again the same matrix in negative. So this is a skew symmetric matrix. So the answer, whenever A transpose is going to be equal to negative A, that is going to be a skew symmetric matrix. Skew symmetric matrix. If A is a square matrix, then A into A is a. See, A is a square matrix. A and A can be anything. We don't know. If you take any matrix, I'm just saying that if you take it as 1, 2, 1, 0 or any matrix, you cannot tell anything. It can be skew, it can be symmetric, it can be diagonal, it can be any of these. So by just saying that A is a square matrix, A dot A is what? You cannot tell, so you have to answer as none of these. Which one? None of these. Right? Just you can take an example 1, 2, 1, 0, you can multiply these two and just say that 3, 2, 1, 2 is coming. So A can be anything. If A and B are symmetric matrices, then A, B, A transpose. So you have to take the transpose of this. Okay, let us see. See, A, B, A. Since A and B are they are already symmetric matrices. Symmetric matrix already given. So A transpose is A, this is given, and B transpose is B, this is also given. We can directly use it. Now let us take the transpose. As I said, X, Y, Z transpose is a Z transpose, Y transpose, and X transpose. Okay. So for Z transpose, Y transpose, Z, X transpose. So A transpose, then we have B transpose, and then we have A transpose. So now A transpose is already given as A, B transpose is B, A transpose again A. So when we transposed A, B, A, we got the same matrix A, B, A. Okay, this is a symmetric matrix. A is the answer. Now A is given as 5xy0 and A is equal to A transpose. So what we have to do? A is A transpose. So let me do it. 5xy0 is equal to the transpose. Transpose is what? Row will be column. So 5x. This 5x will be, the first row will be the column 5x and this will be y0. So let us equate 5 is equal to 5, 0 is equal to 0, x is equal to y. So only we are getting x is equal to y. From this also and from this also, x is equal to y. So this question is only saying that x is equal to y. This is only what we can deduce from this question. X equals y. Okay. Okay. This one we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.